Welcome to iTTV for Form 2 Science, where we continue with the world through our senses. Today's lesson, the sense of smell. Now, one of our senses is our sense of smell. It is one of the most important senses because it allows us to detect changes in our environment that we can't see. You can see when something becomes dark because your eyes tell you. You can feel and touch things with your skin, but when something happens that you can't see because of chemicals in the air that are too tiny to be seen, we rely on our sense of smell to tell us what is actually happening. We smell with our nose. The sense of smell, the stimulus is chemicals. The nose is sensitive to smell. There are 2 million smell receptors in the nose. And believe it or not, in the whole animal kingdom, this is probably the worst of the lot. Most other animals have got a fantastic sense of smell. I've heard a story that in America, they're even using dogs to be able to smell a cancer growing in a patient. Now, for a dog to be able to smell cancer cells inside a patient, it must have a fantastic sense of smell. Dogs, cats, and a lot of the other animals have got more than 2 million of these receptor cells in their noses. Their numbers go up to 10, 15 million. They are so sensitive. There are dogs that can detect explosives. There are dogs that can detect drugs. There are even dogs that can detect pirated CDs. That is how good their sense of smell is. Our sense of smell is not so great. We tend to use our sense of sight more than our smell. But nonetheless, our sense of smell is very important to us. It allows us to detect whether something is spoiled or if something is not spoiled. It allows us to detect when something is burning. It allows us to detect small changes in the air. For example, in a lab, if you had a Bunsen burner and someone accidentally left the Bunsen burner on, you couldn't use your sense of sight to know this. But what you would use is your sense of smell, because you would smell the gas coming out from the Bunsen burner. So our sense of smell is very important in that it can allow us to avoid dangerous situations where there are toxic or poisonous gases that are colorless in the air. The main areas of the nose are the nasal cavity, tiny hairs inside the nose, a special cell lining, and also the nerve cells. Now, what we need to do is actually have a look at the structure of the nose in a bit more detail. And for that, we're going to jump up here to the board and sort of draw it in. Now, I'm not the greatest artist in the world, so let's just try and do this. So we have our head, and then it comes out here, and we have our nose here, and we come down, and then we have our lips here, and then we go on. So what we want to look at is this area here, which is the main area of the nose. This area here. We begin with this opening here that allows the air to enter into our nose. We call this the nostril. Once we go past the nostril, we come into what is called the nasal cavity, which is this area here. Now, inside the nasal cavity, we'll find all the other bits and pieces. The hairs in our nose tend to be at the opening over here. Okay, so these are our hairs. And the special cells that we really want to look at are at the top of our nasal cavity. This is because as the air enters into here, the air tends to go straight up to the top here. So the air goes up to the top here. So in this upper area here, this area here, this is where we have our receptors. So that is basically the structure of the nose. The three main parts that you got to know are the nostril, which is the entrance to the nose, this large opening here, which is called the nasal cavity, and the upper part of the nasal cavity, where we have our special cell lining, where we find our receptor cells. The sensory cell in the nose are called olfactory cells. Now, you need to know that they're called olfactory cells. You can, in the exam, say the receptor cells, but it would be better if you knew that they were called olfactory cells. You may be able to get an extra mark for giving the correct name. So try to remember this name, olfactory. Say it with me, olfactory. Good. All right, let's move on to the next part. Smell receptors are sensitive to chemicals in the air. These are located in the upper nasal cavity. So like I said just now, if we go back to this diagram, it's in this area here. So it's in this upper nasal cavity area here that we find our receptor cells, the olfactory cells. And remember, these cells, like we've just said, are sensitive to chemicals in the air. So as the air comes in, it carries these chemicals to the olfactory cells, and that's where they detect the smell. The sensory cells are covered in mucus. Now, mucus is that liquid that comes out of your nose when you have a cold. When you don't have a cold, you still have mucus inside your nose, but it's just a thin lining. And it's very, very important because it's part of the process of detecting smell. Let's have a look at this in a bit more detail again. Let's just take a small area here and expand it for ourselves. So what we have in this upper lining area are a group of cells which are our olfactory cells. Now, along with these olfactory cells, we basically have a little gland here that will produce our mucus for us. So this is what we call a mucus gland. Now, we've got tiny hairs coming out here like so. This is what happens. The mucus comes out from here and we get a thin layer of mucus sitting here like this. Okay, so this is mucus. So we've got a thin layer of mucus here, and these are our receptor cells over here. Now, as chemicals come in with the air, let's say we've got some chemicals here floating in with the air, these chemicals are going to dissolve into the mucus, like so. Once they enter into the mucus, these chemicals will move towards the receptor cells. As they move towards the receptor cells, they stimulate the receptor cells. So, once again, the chemicals come in, they go into this mucus layer, they move through the mucus layer until they reach the receptor cell. When they reach the receptor cell is stimulated. It's like zzz. And once the olfactory cell or the receptor cell is stimulated, it fires a message to the brain. So remember what the process looks like. The air brings in these chemicals very quickly. The chemicals come in. The chemicals dissolve into the mucus layer. They move through the mucus layer. They excite or stimulate the olfactory cell. The olfactory cell fires a message and it goes to the brain. And then the brain will tell you what the smell is. Is it a good smell, a bad smell, run away from the smell, or go towards the smell? So remember, chemicals, smells will dissolve into the mucus. The dissolved chemicals stimulate the smell receptors. The sensory cell will then send a nerve impulse to the brain. If there is too much mucus, the chemicals cannot reach the receptors. This happens when we have a cold. Now, we've all had colds, and I think you should all by now realize that when you have a cold, you can't really smell anything and you can't really taste anything. The main reason is, like we said, this mucus layer. If this mucus layer is too thick, so that means instead of just being its normal thickness, it's like double the thickness. It's this thick. Now, if it's thicker, these receptors here are too far away from the chemicals. As the chemicals dissolve in here, they just take too long and in the end just get stuck inside this mucus layer. And when you sneeze or something and the mucus layer comes out, well, those chemicals are lost. And you don't know what the smell was that was inside your nose millimeters away from the receptor. But it just can't get to the receptor because, like we said, there's just too much mucus between the receptor and the chemicals. Now that we've gone through this basic material on how the nose works, let's try one or two questions. Question 1. Where are the receptors found in the nose? Remember the diagram that we drew earlier? Are they at the beginning of the nose, in the middle of the nose, at the top of the nasal cavity, at the back of the nasal cavity? Remember, you must know where these receptors are. Let's have a look at the answer. In the nasal cavity. Let's try another quick question. How does the nose detect a smell? So what we want here is the basic idea of what happens. What must happen so that the nose can detect a smell? Have you done this? Have you written it out? Good. Let's test the answer. Chemicals dissolve in the mucus and stimulate the receptors. Remember, the two main parts here are, number 1, the chemicals must dissolve in the mucus. Number 2, they stimulate the receptors. Okay, remember the sequence. Dissolve in the mucus, stimulate the receptors. The next thing we need to do is we need to be able to identify the pathway for a response with our nose. Remember, we did the pathways earlier on. So let's go through a general pathway that we would need for our nose. The nerve impulse pathway in the nose would be the stimulus, which enters the nose, receptor, then the sensory nerve, then the brain, the motor neuron, and finally the response. Always remember, you've got to have the 3 main parts, which is the receptor, the brain, and then your response. And don't forget, like we said earlier in a lesson, that to go from the receptor to the brain, we use the sensory nerves. To go from the brain to the response, we always use the motor nerve, or you can say motor neuron. The nose helps us to detect rotting food or if something is burning. And this is very important for us in terms of our safety. Please understand, the nose is not just there for smelling tasty food or nice food or smelling roses and flowers. Really, the nose is a mechanism or a warning organ that allows us to find out or detect danger in the air, things that we cannot see. So if something is burning, we'll smell it and we'll realize it. If you're about to eat food and the food smells wrong, it smells spoiled, then you avoid food poisoning. If you smell a nauseous gas or you feel a bit weird because there's a smell that is making you feel like you want to vomit, then you know that in the air around you there is a poisonous or toxic gas. Even though you can't see it, your nose is able to tell you that danger is around you in the environment. The next thing that's very important are the nose hairs. The nose contains hairs. The function is to trap dust from entering the nose. Now, we drew earlier in the first diagram the nose hairs which sit at the entrance of your nose. Now, they're really, really important because if you get too much dust entering into the nose, the effect is we sneeze. Now, sneezing produces a lot of mucus. Now, you see the problem that you get here. The dust enters your nose. It causes the nose to produce mucus. When you have too much mucus, you can't smell. So, by having the hairs sit at the front of our nose, we stop dust from entering. And if we stop the dust from entering, it means that inside the nose, the amount of mucus is correct and our sense of smell works correctly. So please understand, important hairs sit in the front of your nose. I know later on in life we trim these hairs. Trimming them is fine, but please do not cut them to the point where they are of no use to us. So please be a bit practical in terms of your hair or your nostril hairs. They have to be there because they allow you to maintain a good sense of smell. The nose helps us to taste as well. If the nose is blocked, we can't taste well. You're going to find that our sense of smell and our sense of taste are very, very combined. I think if you think back in your experience, you'll find that when you have the flu and your nose is all blocked, you can't really taste the food that you're eating. The reason for this is that the chemicals inside the food that you're eating actually go up to the nose and there create a smell. They work hand in hand together. If your nose is blocked, well then unfortunately these chemicals cannot induce a smell and the food tends to become tasteless. Taste and smell go hand in hand. So remember what we've learnt today about the nose. The nose has a very simple structure. It's got nostrils that allow the air in. The air enters into the nasal cavity. When the air enters into the nasal cavity, it brings with it chemicals which represent our smell. These chemicals will dissolve in the mucus layer at the top of our nose. When they dissolve in the mucus layer, they slowly move through the mucus layer until they reach the receptor cells, which we call olfactory cells. When the chemicals touch or come into contact with the olfactory cells are stimulated and they fire a message or a nerve impulse to the brain, and the brain translates this into a smell. There are good smells, such as the smell of your favorite food or a smell of a flower. There are bad smells, the smell of something rotting or the smell of something burning. Smells are very important in terms of our survival. They tell us when there is good or when there is danger in the air around us. Please make sure you look after your nose, meaning that you don't blow it too much, you don't stick anything up your nose, and make sure, and this is the most important thing, that you understand how important your nose is in terms of detecting gases in the air around you that may or may not be dangerous for you. That's all for today's lesson. I hope you enjoyed watching ITTV.